My name is Brendan McAdams. I work for Typesafe in the professional services group. I'm also spending part of my time now working on SliQ, which is our database access layer. It grew out of an old project called ScalaQuery that Stefan Zeiger created. He now leads our SliQ team. And I want to talk about what SliQ is, some of what is coming in the future, but also sort of how we use it, how it looks under the covers in some ways, and I'll give you guys a taste of a different way of doing things, and hopefully an idea of why we might want to do things the way that SliQ allows us to. So SliQ stands for Scala Language Integrated Connection Kit. However, at some point not so long ago, we decided to make it not all capitals. It's capital S and the rest is lowercase, even though it's an acronym, so just keep that in mind. So this is meant to be an elegant, functional database library for a more civilized age. And this is the one and only time I've ever put an audio sound in a slide, and I sort of regret it now. It was cheesy when it started, now it's just silly. But this is the idea, and I'm going to talk about some of why we want to do this. But the reality is, think about the concepts behind relational databases. You've got COD's 12 rules from what, the early 70s, late 60s. And they were meant to solve a very particular problem, but we were also working with very different types of tools and programming languages at the time. And I think we've hit a more civilized age. We're starting to take these concepts of functional programming from the research world, the academic world, and move them into production programming, and there's a lot of changes happening. But we, for the most part, apart from this NoSQL movement going on that I've been part of, so I should be careful about how I describe that, we haven't really changed the way that we access our databases from code, and in some ways it's gotten worse. So why we're here, and why I want you to sit here for the next hour and hopefully nobody runs out, I want to talk about some key concepts. So first of all, the functional data concepts, which is how we work with collections in Scala. How many of you consider yourselves to be Scala experts? With a show of hands. I don't see anybody's hand up except Sanjay here in the front. So I want to review a little bit about how you manipulate collections in Scala. And the reason why is this. If you know how to manipulate a seek in Scala, you know how to manipulate a database with SliQ. So we're going to review how we do that so that you guys are comfortable with that. And then I can unleash you on just playing with SliQ because you know everything you need to know. A little bit about the concept of an impedance mismatch. And this is where code and data fail to meet. And that's that part I'm talking about of this more civilized age of finding a better way to work with our information. And how we map Scala's functional collections, because that is the key concept of Scala that really makes it stand out, is that the collections are functional. We can pass functions in and manipulate that information with functions. So what do we aim to solve with SliQ? And the idea partly is that we want our code and our data to be in harmony. So SliQ is a database query and access library for Scala. The idea is that SliQ is supposed to allow us to work with the database. And we can write native Scala syntax to do it, which is a little bit novel. This is a different way of doing things. We let Scala generate our data access for us under the covers. And this means no more SQL. This is without us needing to go over to NoSQL, because one of the things that's driven NoSQL over the years has been people who are tired of writing SQL, tired of data models that don't match up with their code, tired of using Hibernate, for example, which as far as I'm concerned is a good enough reason to get rid of every SQL database on earth, is using Hibernate. You can still write SQL if you need to. I'm not going to talk about it today or show it, but there is a layer in SliQ that allows you to write SQL directly if you need to and to access the JDBC layers. And we are working on adding NoSQL support. That's actually one of my projects. And so in the next few months, you're going to start to see us take all these concepts and apply them to more than just SQL databases. SliQ 1.0 is out now. This requires Scala 2.10 plus. 2.0 is currently in a milestone cycle. So I think M2 was released a few weeks ago, and it's still like pre-beta. It's not really production ready. There's still some initial concepts and ideas and other things that we're playing with, but we are evolving fairly quickly. So we went from 1.0 to 2.0 because once 1.0 got out, we had a lot of new ideas and other things that changed rapidly, and we went over to 2.0. The work that I'm doing on NoSQL support is targeted against the 2.0 release. What I'm going to show you today are going to be examples from 1.0, because 1.0 is currently the production release and the one that you're most likely going to be working against. And this is from the same people who brought us Scala. It's the team at Typesafe and a number of people at EPFL who are working on this. So the two main developers on SliQ are Stefan Zeiger, who originally created ScalaQuery. He works for us at Typesafe. And Christopher Vogt, and I apologize that I probably mispronounced Christopher's last name, Christopher works for EPFL, where he does research and other things. And the two of them together have driven a lot of the work on Slick forward, and I'm starting to come on the team and pretend like I'm actually an equal contributor, and I feel a little overwhelmed at times. So what do we support? We are focused right now on relational databases because that's the core area that Slick was originally built for. But like I said, we're going to expand that. So we support Postgres, MySQL. We support Microsoft SQL Server. There's two things with that. I in my distant past, did a lot of work with Sybase. And anybody who remembers the history, for a long time, Microsoft licensed the Sybase source code and repackaged it as SQL Server. So they actually have the same protocol. Even when Microsoft bought the rights to just go off on their own, and there's actually a couple of open source libraries that can connect to both Sybase and SQL Server. So I'm curious to play with it at some point, but I bet we probably could make Sybase work, given that we have SQL Server support. We support SQLite, we support H2, Derby/JavaDB, HyperSQL, which is usually known as HSQLDB, Microsoft Access for some reason. And in 2.0, there's actually a really cool in-memory driver. And I say it's really cool because it's actually been a really great model for me, adding MongoDB support. The in-memory model drove a lot of moving away from everything being hardwired for SQL. And so I actually finally started looking at the in-memory driver last week and realizing that I've been banging my head against the wall looking at the JDBC stuff for examples because the in-memory driver doesn't use SQL. It just maps your Scala code directly to an in-heap data structure. Now there is something that I should note. The items that are on the left for 1.0 are all part of the open source package of Slick and they're completely free. For 1.0, Oracle and DB2 require a license for Typesafe for usage. With Slick 2.0, anything that's considered a proprietary database, so that would be SQL Server moving into the big red box, is going to be moved over to the concept of being a proprietary driver that you'll license from us. So if you're using an open source database and connecting Slick to it, there's no license or anything else. If you're connecting to a proprietary database like Oracle DB2, SQL Server, then you would get a license from us to use those extensions for Slick. I'm not actually sure off the top of my head how those are distributed, whether they're freely available for development, but I can find that out if anybody needs that info. Now, what's coming real soon now, what I'm working on, the first thing we're looking at is MongoDB. We're also looking at a couple of other NoSQL databases because we don't want to just be Mongo. Even though people know me as the person who did a lot of work on Scala and Mongo, I do have interest outside of that. Now that I no longer work for the vendor behind Mongo, I can play with other NoSQL databases. And that includes things like Riak, Cassandra, Neo4j, and seeing how these map and if we can make these things work. So, as far as examples go, Stefan has done a bunch of demos in the past, and he uses coffee as examples. And one thing I want to not feel like I'm just cutting and pasting Stefan's slides, even when I am. I also change it up a little bit because I tend to drink more tea than coffee these days. Coffee eats a hole through my stomach, the curse of 15 years as a programmer. Also found some really good tea around the world, so there's that. So let's look at how we might track data about tea in Scala. So what I've done is I've created a bunch of tea vendors from around the world. Some are very expensive, and some teas that they sell. What I typically did was pick the most expensive tea that each vendor sold and pop them in there. We're going to work entirely with an in-memory collection of data. Now I should separate that out. We're not using the new in-memory stuff in 2.0. We're using, I believe, H2 or HSQLDB. So it's using a Java JDBC driver that behind the scenes is in memory. Now I want to start, before we look at the SQL, and look at some Scala. I should clarify this before we go forward. The examples I'm about to show you are pure Scala. Imagine if we're just building our T data in Scala data structures and manipulating them to review how we work with this information. So I've created an enum in Scala called T types. And there's several types. There's black, white, oolong, and green. Interestingly enough, there is at least one large tea vendor in France. I don't know if all of them do, but Mariage Frere sells oolong as purple. They're very consistent on everything has a color. And for a long time, I had no idea what purple tea was, and I got blank stares from the guys at the shop until somebody finally explained that they call it oolong. So I kept it as oolong, because everybody knows oolong. We have a case class, which is a supplier. Does everybody know what a case class is? Does anybody want to tell me what the properties that I automatically get from a case class are? Okay, we get setters and getters. What else do we get?
Pattern matching.
Equal, I heard equals, I heard hash code, anything else?
Pattern matching.
To string, and we get constructors, we get pattern matching, so there's value to using case classes. So I've created a case class here, I've got a supplier name, I've got the country that they're based in, and I've got a URL, which is a JavaNet URI. I've also then got T, and T represents some item of T for sale. And that's the supplier, the name of the T, the color of the T, the size, 100 grams, a pound, whatever else, the currency that it's sold in, and the price, which is a double. Everybody okay so far? So this is enumeration, values of color for T, a container class for T vendors, and a container class for T types from specific vendors. Now let's put together some lists of T. Let's actually build some data that we can work with to see how we manipulate this information. And so here I've got a bunch of suppliers, and some of these, most of these are places that I've actually had T from, and they're all fantastic. Stash is based, I think, in Oregon, but there's a couple of really fantastic ones in here. I'm a big fan of Mariage Frere, except it's expensive. So, you know, usually I drink it when someone buys it for me as a gift. I was not soliciting for gifts, for the record. I just pointing out more, like usually someone gives me a box of it, and it's very, very good, but expensive, as we will see. So each of these is a supplier. We've got the name, their location, and their URL. Now we know what we know who's selling, but what are they selling? And so I've got a whole bunch of T's here. Now each is broken up by comments, and as I mentioned, you will see there are some expensive ones. Mariage Frere sells a white tea that's 105 euros for 100 grams. A little bit pricey. It's worth it, but it's very pricey. Stash is relatively cheaper. You're looking at 100 grams for about $7. And each of these is a construction of our case classes. And a few other random choices from various vendors. If you want to take a look, I have put a copy of the code that I used to build this at GitHub. And it's BW McAdams. And it's slick-talk. And there's a copy of all of the code that I use here, and you can do SPT run, and it will actually run it and print out all the output that I'm going to show you. That actually is the example with the running Slick as well, if you want to play with that. So we've also got, you know, a really nice Darjeeling here from Palais Teas, which is 56 euros or $56 for 100 grams, because when you go to their website from the US, they show you their prices in dollars. So how do we connect and manipulate this data in Scala? Hopefully, is anybody here not sure what we're going to do next, have no idea how I might filter and manipulate data? Okay. Well, I'm going to show you anyway. So I've created a sequence here. I've collected a bunch of instances of my T, I've created a sequence, and I've saved it in the variable T. Now Scala's type inference figures out it's a sequence of T. Hopefully everyone's okay with that. I'm not going to go into all the different choices we could use for a seq. I probably could have used a vector instead, but this is a collection. It holds a list of T's. Now, it would be the same if we explicitly declared the type. What exactly we can do with the sequence is where it gets interesting. So, first and foremost, with working with Scala collections, we're talking about functional programming. I'm hoping by the end of today, or at the end of the day, everyone's comfortable with this concept. I hope that everyone guessed that functions are involved. You've also probably heard the term lambda thrown around. Java 8 is adding them, for example. Lambda usually refers to an anonymous function, a function that's not specifically addressed with a value or attached to a method. Methods are named in concrete. Scala does have the ability to lift these methods into functions as needed. So, real quick, this is a method, it's well defined. It's a method costs dollars, it takes an argument of t and returns a boolean, which checks whether the currency is in dollars or not. That's all that it does. And I also have a function. This is an anonymous function, or a lambda. I just happen to have captured it into a value. It still will take an argument of type t and return the boolean to me, representing what it does. So this is our core unit of work. We're using Slick and everything else for the manipulations we're going to do. And the rocket indicates a function, or a lambda. The left side declares the arguments to the function, and the right side is inferred here as Boolean. So we can use this to define functions and methods that take functions. This is one of the two things that defines a higher order function. Does anybody remember what the other definition of a higher order function is? So a higher order function is either a function that takes a function as an argument or returns a function as a return value. And so that's important because this is something that makes it really easy for us to do cool things in Scala and with Slick. So here I've got filter, which is something that's attached to that sequence that we created. Is this method filter that takes a function which takes an argument of t and returns a Boolean. So I can do that to evaluate, finding all the items that have a currency of euros. And filter is built into the Scala collections. So if we look at this really quickly, it's a predicate which is evaluated against each entry for truth. For each item in the collection, we run that predicate function and we say, do you match, yes or no? And we only return the items that match that predicate. And we return a new sequence of t with only the true items. So whatever the input function is what the, whatever the input type is what the output type is going to be. And then we can pass the function we write in line even. So I say val in euros, which gives me a sequence of all of the items where the currency is in euros. So now I find all the t that's for sale in euros. And I could do the same with other currencies as well. So this is a new sequence of t. We also can lift our method. So if any time that Scala needs a function and is given a method which has the same argument signature, it can lift that into a function. So here I've defined cost dollars as taking t and returning if the currency is in dollars. And that's lifted up automatically in. And hopefully everybody's seen this before or is at least somewhat comfortable with what I'm showing you. Now would be the time to run out of the room if you're really confused. Or at least let me know if you want me to explain further. I would prefer the latter. So we've got a new seq of t. Now, exists is another one. This is, again, fundamentally part of what we have, which is I'm looking at any elements that match the predicate existing in the sequence or not. And so, are there any items that are sold in rupees? As far as I know, none of my vendors sell in rupees. You know, a lot of tea comes from India, so maybe there's one in there. And so I say t.exists, t.currency is equal to the rupee symbol. And that will return me true or false. And then finally we've got group by. Now this is the part where we start to really feel like SQL because grouping is a big part of what we do in a SQL database. And Scala has a function called group by that's designed to do just this. So with group by, we take in a type of k, which is used for the grouping. It can be any type we want. It's what the type that's coming out is going to be. For each entry, we want to transform it into k. So really what we're doing is we're looking at the item and we're turning a key that represents its grouping. And then we get back a map that's grouped by the key and then a sequence of all the items that were attached to that key. So here, if I group by kind, I say types of t is t.group by t.kind. I'm going to get back a map by t-type color. And I can even easily recast that as a string, so it's just something legible on the screen. And string ct. And so tentries.t.group by t.kind.toString.keys is going to be a set of white, oolong, black, and green. Now we can apply all of these things to doing SQL and to having Slick take these functions, because these are all the fundamental operators that we need in order to work with data can be translated down to SQL for us. There's one last transformation function I want to mention, which hopefully you guys have seen, which is map. And map is going to give us back a new sequence of b. It's a transformation. It takes in an item and transforms it into something else. So if I wanted to format all of my items, I could make the value of prices be a map where I format it so that I get the currency, symbol, the price, and the size. So I'm saying it's $100 per gram or whatever else. Sorry about that. So let's create our tables. Let's actually apply this and really look at Slick. Now there are two main ways of doing work in Slick. The one that we most often work with right now is called lifted embedding. And lifted embedding is very clear that we're writing some special code for the database. There's another type called direct embedding, which is experimental, which when finished will allow you to basically annotate a case class with Scala annotations and use macros under the covers to convert that down to code. The lifted embedding is fully functional, and that's what I want to focus on for today. So I've defined a table called vendors. And you'll notice that we extend the class table, and then we provide a tuple with the types. So we have to have all of the types that go into the table. Now the one thing to keep in mind here, obviously, is this limits our table, our number of items in the table to 22, which is the arity limit. But it's int string, string, string. And there's another argument to the constructor, which is the name of the table in the database to use. Because there's one of two possibilities. The table may already exist, in which case I'm going to use my code to read from that table, or I have the option of creating that table, in which case we'll create a vendors table. Everybody okay with that so far?
So the table already exists. We're just mapping to it. We're not.
We're just
overriding.
mapping to it. I mean, so if you call the DDL create command, it would give you an error because the table already exists. So it would attempt to map what we've defined here onto the table that exists and read from it.
So this will return an error on a table that already exists.
If you tried to call create on a table that already exists, you would get an error.
Oh, this is
If
not
you
a
just-
create statement?
No, this is just a, so this is a definition in my code
Okay.
that says how to map between Scala and SQL. We have the option to create a table from this definition, so this can be converted into a create table statement, but we don't have to. Yes?
So this was called lifted embedded, sorry.
This is actually the direct embedding.
Direct.
Yes. So wait, no, I'm sorry, this is the lifted embedding. My brain is not working. This is the lifted embedding, everything's being lifted up. The direct embedding uses macros.
So if I were to do a create statement, then I would need to go through an evolution, go through like evolutions everywhere.
Correct. Now, I don't really think we have support for true evolutions, so there's not really support for I've evolved my code and with the next version, but you do have create, drop, I mean, there are DDL interaction commands built in that work here. And you know, and evolution may be something that we add in later. Yes?
Can you talk, unless you're going to get to it, can you talk about the difference between extends table of int, string, 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 and string, int, string, string?
So it's the order that the columns are defined in, and I don't know whether it's going to make a difference. I think it's going to depend on the database. Some databases are fairly strict about
Some can be
ordering.
unreliable.
What's that?
And I feel like some can be unreliable. Under certain.
Yeah, I'm actually not sure on that. The best bet would be probably to email me that question, and I'll get Stefan to get back to you. I don't know, actually. I would do it in the order that's defined in the database table, just to be safe. That's usually how I do things, so I'm used to exactly what you're describing, which is some level of unreliability. Now, each of my, you'll note here that I haven't defined vals, but instead I've got depths. So I'm defining methods, and this is that part where we talk about this being lifted embedding, because these methods will be lifted as needed into functions. So I've defined ID, and to define that, I actually call a function called column with a type argument. So I'm creating an int column on the field or the column name vendor ID, and I'm also giving it an attribute called primary key. So this tells Slick that this is the primary key. That also means that if I'm going to generate a DDL from this, it's created as a primary key. We also have name, which is a simple column string vendor name. We have country, and we have URL. And in this case, I simplified things versus my original Scala example. URL is just a string now because not every database has a URI type, and Slick doesn't fully map that, and I didn't want to get into custom types. Now, the last thing that needs to happen, and if you've played with ScalaQuery, you may have seen this before, is that in order to tell Scala, because there's no macros in use here, what fields are available, we define a special projection method called star. That's an asterisk symbol. And that's going to be each column combined together with a tilde operator. And that's that final step that tells Scala, if I was to basically do the equivalent of select star, what columns are included in select star. And that's where that mapping is. If you think in terms of select star, that's what that is. Star has to represent every column that's been defined inside of this table.
Slick does not automatically include all the columns.
Not with the lifted embedding, because there's no macros or anything else in place to figure that out. With the direct embedding that's coming down the road in the next release, there will be some ability for that to happen automatically.
So basically, Slick, based on this definition, to understand what's the table structure to generate the query, SQL query behind us.
Correct. We have to tell Slick a lot more than maybe down the road you might have to as we evolve the product.
Does this also cover foreign key and all those stuff?
I'm about to show you foreign keys on the next slide. Yes.
So this code basically creates a table, right? Because we specified there that the first field is the primary key.
You can use this to create a table. If the table already exists,
Yeah.
you can use this to just read from that table.
Okay, but I think we're repeating ourselves when we are specifying the types in the table, in the brackets, and then below we enumerate all these columns again. Because if we need to add one more column, we'll have to make 2 changes.
It's true, and that's because this, with generics in Scala, we don't have in Java you can ignore the generics, and in Scala we are required to specify the generics. And so table there's really table 1 through table 22 where they take the type arguments, and it's essentially a requirement of the type system. And again, these are things that as the product evolves, we're looking at the direct embedding, there will be solutions for making it easier to do that. But right now, you do have to declare that in 2 places.
3.
So let's look at our T's table. And again, we have object T's, it extends table with our types, and we have our table name. Now obviously everything else is fairly similar here. We've got our primary key, we've got our star. But here's what's interesting. I've defined vendor ID. So vendor ID is a column of int called vendor ID, and that's going to hold the actual ID from the vendor table. But there's an additional method that I've defined, because when I'm working in my code, I don't want to have to manually resolve vendor ID into a vendor object. And so I can define this method here. And this is a reified foreign key relation. So we can navigate this to create a join automatically. And so what I say is that basically defining the field vendor, and that is a foreign key that in the database, if I was to create it, is going to be called vendor_fk, that relates to the vendor ID column and the vendor's object. So the vendor ID column matches to the vendor's table, and in order to resolve a vendor, I use the ID field from the vendor's object. So _.id says from vendors, get the ID field. And so now if I call vendor, I will automatically resolve the vendor behind the scenes and get back an object of vendor. Was there a question in the back there? Yes.
So you don't have to have that.
Actually, behind you real quick.
Oh no, I was just wondering, we don't have to write this. Do you have a tool that automatically generates this from the database metadata?
There is some work being done on that. I think Brandon Hudgens did a blog post recently that he's been working on a tool to generate slick DDLs from existing tables. Was your question?
You don't have to have that vendor FK object actually named that in your database, or?
No, that's just how I named it.
Okay.
It's been a while since I did a lot of work with SQL, so I'm a little rusty with my names, and I like making DDAs unhappy, so I probably did that deliberately. But that would be, if you were to create the table from here, that would be what it would be called. It doesn't need that in order to resolve it if the foreign key already exists. Really, the important part is saying that the vendor ID column relates to ID on the vendor's object and can be used to roll things up. So let's take a look at sessions and DDLs here, and I think the code's a little small, I apologize. So there is an implicit called thread local session, which keeps our session in a thread local and scoped to the current thread, which we're importing at the top. Now, database.forURL allows us to construct a driver and connect out to a server, and that's what I'm doing here. So I'm using JDBC, I'm using H2's memory driver and the test1 database. And then specifying that the driver is org H2 driver. All the fun of JDBC is still slightly exposed here. And then with session actually is a loan pattern that everything happens within that session. So inside with session, we have an implicit session that gives us certain objects that let us work with the database, but outside of the with session method, you don't have direct access to that data. So the session is never named explicitly. It's bound to the current thread using the thread local session that we imported. And we can create the tables, and that includes the primary and foreign keys. And you notice here that I've done 2 things. I've said vendors.ddl ++ tees.ddl. And that will return me, .ddl will return me the constructor statements, and I can combine those together and then call .create. And that just says go out and create the SQL tables for these 2 items. And then I insert some suppliers. So all those suppliers I showed you before, Stash, Mariage, Frere, etc., have all been created with vendors.insert. And in this case, it looks like an insert statement. Vendors.insert and each column is defined. So 1, comma, stash, comma, USA, comma, stash t.com. And we can also insert some T. Now here, we can use the JDBC batch insert feature if it's supported by the database. Otherwise, you would have to do individual insert statements. So at the bottom here, I've actually done an insert all, and I apologize, it's a little small on the screen. Insert all, and then it's just a bunch of tuples that define the columns, and these are all bulk inserted directly into the database for me. And you'll note, in this case, I've got Darjeeling Estate Golden Tip, and then 1, which is the vendor that sells it, so this is sold by Stash. Black, dollars, 15, 100 grams. And now all of our data is in here, yes?
So you have to point at it to the vendor ID. You couldn't somehow load the object.
You could, if you wanted to. I mean, if you had an instance of the object, you could easily do that, as long as it resolves to an int. But for quick and dirty creation here, I whipped it up with how I would probably write a SQL statement by hand if I was to create all the data. Now, basic data iteration looks and feels quite a lot like Scala. We use the object query and pass it the table that we want to query against. So in this case, query T's is going to give us the ability to query against the T's table. And now I can actually do a for each iteration. And in there I say, in the case that the item you get is name, comma, vendor ID, comma, kind, currency, price, size, so I extract all of that. And I'm just doing a print here. I'm doing a println with some formatting to make it look pretty on the screen. And it actually looks a little uglier on the console, but I formatted it so it's readable. So essentially, this data came cut and paste from actually running the sample code that's up on my GitHub, and it spit right back out onto the screen. And so I've got each item. I've got the name, tab formatted, vendor ID, the kind, the currency and price, and the size. So this all comes from a simple iteration that all I really had to do was put a query call around my table, and then I work with it almost as if it's a normal Scala collection. So why not let the database do the string conversion and concatenation for us? That is possible if we want to, if the database supports it. And so this is a little more complex, but I basically save in valq1 for TTs, and then I yield const column. So const column is a shortcut in Slick for anything that's declared as a constant. So if I say 5.0, that's a const column of 5.0. That's a constant statement that's passed into the database in whatever way is necessary. So the const column, open quote, space, close quote, is me adding a space in. And I'm just tacking each field in. So t.name ++ tab ++ t.vendor ID as column of string. Now that lets me convert. So t.vendor ID would come back as an int normally, but you can't do a string format in the database with ints and strings, so I convert that over to a string. This is using a standard SQL cast. And then ultimately, I do a for each and print line my results, and I get back the same thing relatively, and that comes right from the database. Now, resolving relationships is yes.
The data would be null in this case. Would there be any exception or something? If I would say currency is null or...
I think it depends on the database, how the database would handle that, because this is the same as doing a formatting in the data. And I think I don't remember if databases will throw an error on that being null. I think they'll just put them in as null or as blank. It's going to handle, so under the covers we're using a JDBC driver. So it's going to handle things just as if you're connecting directly to JDBC, at least as far as an exception being thrown isn't going to be changed.
Well, pretty much in Java, like when you apply functions like as column or something to an object which is null, I would expect a null for the exception.
So would it be like an option string?
There is an option, and I'll show you how to do that as an option later. I don't know that I would recommend doing formatting because exactly what Sanjay is pointing out, which is it's null, it could throw an error or something else, but the more important thing here is to look at things like the ability to do as column of, the fact that you can drop this stuff down to the database if you want to. But you also can do it from Scala.
I mean, these are casts, though.
Right.
SQL casts.
They're SQL casts. That's the most important thing. The casting is happening here in the SQL database, not in Scala. So the SQL database is going to determine how to handle asking to cast, say, a null item to string. And that should affect your decision as to whether or not you really want to use this style of pulling data from the database, or if you want to format it in Scala. It may be easier in Scala to determine whether a column is null and formatted appropriately. So to resolve relationships, so if, for example, I want to perform a join, I want to get my T names back and my supplier names for all the really good stuff, regardless of currency. So I'm looking for anything that's more than 25, no matter what currency it is. I'm pretty sure none of the stash stuff will show up here. So I do val q2, and then I have a for comprehension or for expression where I get T, and I'm on the T's table, because remember in a for comprehension, if you produce an iterable in, it'll pull out each item one by one. So T's if T.price is greater than 25. So whatever currency it is, we're only allowing the next item in the iteration to happen if this is past 25, in which case then we look at the vendor. So we get each vendor out if the vendor ID, and notice the triple equals here. For those of you who sat in on Bill Venner's talk, he talked early on about the fact that there's problems with using the single double equals. Not single double equals, with using the double equals. It's not a single double equals, it's just double equals. Because some of it is deferred to Scala and it does simple comparisons. And so in a lot of cases, including SLIC, you will see a triple equals, which allows the developer to more closely define how things work. My understanding is with the upcoming direct embedding, which is macro-based, equals will work because we've got control over how that's evaluated. But there is a triple equals here. So I'm asking if v.id is triple equals to the T's vendor ID. So I'm matching up. I'm doing a join here under the covers. And then I'm yielding T.name and vendor name. And then for each item in the query, I print line, and I get back a result like this. White tea from beyond the sky, supplied by Mariage Frere, etc. And so these joins, it doesn't look very much like SQL, does it? It looks like we're manipulating some Scala data object, and that's generally the idea.
Does that convert to an efficient SQL statement?
It does. And I believe you can call .ddl from it, or there's a .SQL that will print out the SQL statement that it's going to use.
How does that work?
Each driver actually has its own compiler. So that allows each implementation for each database to generate efficient SQL from the SLIC AST.
So you could do the profiling on? Can you see the value we're passing to it? Or getting?
You can. So there is a .SQL call, I believe, that will spit out the SQL statement. And then everything can be tuned in the individual driver.
So does price define greater than?
Well, price is a double.
So, I mean, the way this must work is T's has a flat map. Oh, then there's a filter.
Right, it's a filter, but it's going to be...
Filter must be past something that's not just a function.
Let's take a
It
look.
must be past something that can be compiled to
I have
SQL.
my console open. I think it's this. I think it's .SQL.
Statements, or select statement.
Say again?
It's all dot select statement.
Ah, there's Sanjay's been working with the actual stuff more than I have with it. Let's take a look. Because the easiest way to answer the question is let's take a look at what it generates. Now, I will show you some of the diagrams of what's happening under the covers. And specifically, each driver has its own compiler that's responsible for turning that SLIC AST into SQL. So here's my SQL statement. Select x2.tname, x3.vendorname from T's as x2, vendors as x3, or x2's price is greater than 25, and vendor ID is equal to vendor ID.
That's it, that's profile.
Okay. So that's all you have to do is call select statement or whatever else is under the covers, and you can see exactly what it's doing. Like I said, because each driver implements its own compiler, the other thing you don't get is, I think there's a trap that a lot of ORMs fall into, which is that they generate one SQL statement for every database, and so you end up with inefficiencies that usually drive DBAs a little nuts. And so the idea here is that each database should be able to tune for whatever it's doing. Really? Hold on a second. This is what I get for dropping back in the console. There we go. Sorry about that. So we can do the same thing just using the navigable foreign key. So notice the difference here. Here I said if v.id is equal to the vendor ID. Here, I'm just saying if t.price is greater than 25, and then I just iterate to t.vendor. And under the covers, SliQ is going to do the same thing. It's going to figure out, based on what I'm saying, that I want the vendor to match. So only pull the vendor out if there's a matching vendor. This will compile to almost, I think it compiles down to the same SQL statement. This is an efficiency to make it easier for us to do this kind of work. This time I want to read the results into a list instead of just printing them. And so I can just, I can say q3.list and I'll get back a list of whatever the result set type is, which in this case is a tuple of string and string. And my print line will look the same. Oh, of course, my next slide reminded me of exactly how to print the select queries. Sorry about that. So it is .select statement will print out whatever the SQL that's been generated is. That SQL is generated by your individual database driver. And so they have opportunities to tune for whatever that database may be. And so in this case, it's going to look exactly of saving myself the trouble of having to drop back out the console. We're going to get the select statement here, and it's the same statement here as it was in the last one, because saying vendor is the same as actually manually resolving it.
Question on that.
Yeah.
Here for the simple join, is it possible to have left joins and right joins?
It is. I'm going to talk about those a little later in this. I will show you some examples of doing left joins and outer joins and everything else. So real quick, there's a couple other pieces of computation we can do. I can compute the number of actually T's in this case. I meant to update that. The number of T's offered by each supplier. So I say, I just iterate over each T, and then I do the vendor match. And I yield a group by statement. So that's a Scala group by, similar to what I showed you before, that under the covers becomes a grouping in SQL that then groups for each type. Now, note that there's a .get here, and that's because SliQ can't enforce statically that the supplier is always available, because it's a non-nullable foreign key. So we wrap it in an option, so you do have to call get. Because the foreign key doesn't necessarily have the foreign entry in the other table. It's always an option. And so here we do our printout, and I have 4 T's from Stash, 3 from Mariage, Frere, etc. Now, why do we want to do all this? I guess that should be part of the question, and I wanted to show you what SliQ looks like before I try to convince you that you need SliQ. And one of the things is Ted Neward has said that object relational mapping is the Vietnam of computer science, and there's a write up there. It's bit.ly/orm-Vietnam if you want to read more about what his thoughts were. They're very cogent. Having worked, I spent the last 3 years prior to this December working on MongoDB, part of the NoSQL movement, and spending a lot of time moving away from relational databases, so I can sort of see it. And I think the reasoning behind why things are happening like people are moving to Mongo is that our databases and our code have come into conflict. They don't really play nice anymore. And that move is changing. And it's not just for scalability, but for data interaction. One of the reasons people love Mongo is it's a bunch of JSON. And they can work with that really easily in Python and Scala and Java and whatever else they need to do. And they don't have to learn SQL or anything complex. And part of it also is we want the way that we work with our data to match up with how our data is stored. And that gives us a really big mismatch between SQL and object-oriented programming. And even with functional programming, although functional programming in some ways is closer to SQL. Something as simple as a field projection. Give me a small set of fields. Doesn't match up well. When you've got an object that says these are the fields that are part of the object, say a case class, you can't project only part of those. Think about now why in the lifted embedding, I define everything as a def. It's not a val, because I want to be able to pull out each item as a projection however I need to. And so we usually end up building fun, new, ridiculous DSLs to give us some way of querying from our OO world. So if you adopted Hibernate, you got away from SQL and instead you had to learn the Hibernate query language. It wasn't really an improvement, and it sort of showed me that somebody was either having a really big joke on us or missed the point, or both. I mean, that's the thing, was we shouldn't have to learn a whole new language. The idea with Slick generally is you should write Scala code, and you should move forward with Scala code. So the functional language that we use to work with Scala collections maps cleanly to how we manipulate these collections. We have a couple extra operators that we need to do SQL-y stuff. So I don't know why there's a button that turns off my screen on my clicker, but there is. So I have a relation here. Supplier is a relation. It's another object that I want to point to. Currency is an attribute or a field. And anybody want to take a guess at what that seek is?
Table.
It's a table. Because each entry is a row, is the equivalence of a row. That's all that a table really is it's a collection of rows. In this case, it's a collection of well-structured rows. So this is a seek of T, which means that there's a type requirement that's enforced by the database that actually is logically fairly close to a generic system. You have to meet this requirement of typing, except we don't have inheritance and other things in most SQL databases. So the biggest problem is that SQL doesn't compose. And there's that word. It explains most of it. Because what's great about what I'm showing you is I can compose functional statements, but we can't really compose SQL. We can't easily add manipulations onto an existing query. You can't chain operations in a SQL string. You would have to rewrite the SQL. And if you're lucky, you don't create a Cartesian product in the process. So the other problem is that generating SQL via string manipulation, which is traditionally how they've done it, and I'm going to bet everyone in this room at least once has generated SQL and probably written a library that they released to some thing. I think there's probably at least one library on the Perl CPAN that I wrote that I was probably very proud of at the time. One of the things that happened, and what's funny is actually there was a spelling mistake in this slide that I fixed earlier today. Spelling mistakes and type errors are not caught at compile time when we generate SQL. So if we misspell select, we don't find out about that until runtime. We may as well be running Python or Ruby at that point because we're having the same problem. Okay, part of our code is compiled, but our SQL isn't type checked, and we lose that benefit. And so that's something that something like Slick can help with, which is that we can do this generation and checking in a way that guarantees to us that we're generating something that's valid. And the SQL injection is generally the bane of every developer. Either you spend a lot of time up front trying to prevent SQL injection, or you spend a lot of time on vacation logged in remotely fixing whatever somebody did to your database because you didn't protect against SQL injection. And so generally one of the ways you can fix that is, well, hopefully you trust someone else to build a library where you have the benefit of it being an open source library that everyone else finds mistakes and contributes them back to one source. We're not all reinventing the wheel. And I can't talk about SQL injection without little Bobby tables. And I'm pretty sure that I don't think you can actually put SQL on a birth certificate, but you know, if you could, it would be a fun experiment to try. I do know the Perl mongers, which is the user group for Perl, originally tried, when they originally registered in New York State, they were supposed to be Perl mongers with a regex. It was mongers or mungers. And New York State refused their corporation application saying that there were invalid characters in it, which is how it became just Perl mongers. So I bet they probably have the same rules for birth certificates. So let's look quickly at the types of SQL interaction. We've been looking at the core Slick API, which is the lifted embedding. It is possible to do other things. We can invoke stored procedures. We can call raw SQL, but that is a topic for another time. I think if you guys have the fundamental concepts of Slick, you can run off and play with the documentation and figure things out. And the docs are up there at slick.typesafe.com. But I want to take a quick look at how the lifted embedding works. And I actually changed out this slide because there's a new diagram that Stefan put together that also shows how direct embedding works. So this is both with the direct embedding and the lifted embedding. So the lifted embedding converts to a Slick AST. That's an abstract syntax tree. It's sort of like a raw baby programming language before it gets compiled down into bytecode. And the query compiler converts that into an even more refined version of the Slick AST. So this is things like refining types, checking for errors, simplifying potentially complex statements. It's multiple phases, just like the Scala compiler does. If you ever look at the output of the Scala compiler from phase to phase, you have some pretty hairy code at the beginning, but by the time you're done, it's scraped off a lot of the mold and other things to get you down to compiled state. And that runs in the executor, which goes to the database and returns us our result. Now there is also the direct embedding, which is experimental and still being worked on, and that runs at compile time in Scala rather than the runtime that we get with the lifted embedding. And that uses Slick's macros to create a Scala AST, which is then run through the query compiler, refined, executed, and given as a result. And generally, a bunch of the things that you guys asked me questions and said, wait, I really have to write that code myself, will be handled in the direct embedding. So the lifted embedding, let's look real quick again at a statement in lifted embedding where we say T's if price is less than 9, and then the supplier, we yield the name and the of both. And then we run that. Huh? Because I think the original example was coffee, and I didn't swap out the variable. Sorry about that. That should be T if T.price. But we get a table query, we get a T's object, we have a column, double. There's column extension methods less than, column double, and there's a whole bunch. You can sort of see the picture that I'm building here, which is that these all compile down to things under the covers in Scala, which represent objects that eventually can be converted into SQL by your individual driver. And eventually, this will work with Mongo as well by converting down to a Mongo query, which doesn't use SQL. And ultimately, we get a query of column of string, which returns a string of string. So what is Slick doing to compile queries? First of all, we have immutable ASTs. These are types that can't be mutated until they're observed. I'm sorry, they can be mutated until they're observed. So you have the ability to manipulate them until you try to use them. There's an immutable compiler state, and this means that the AST and the phase output state can't be changed. And the phases, just like in the Scala compiler, transform the compiler state. So we go from step by step, we mutate locally that state to create a more efficient query. And the drivers provide their own compilers. And like I said, this is really important because this means that we can write efficient queries for a given database. If there's some dirty Oracle trick that one of you guys knows and you look at Slick and go, hey, Slick's queries are really inefficient, you can fix the Oracle driver without having to change all of the other ones or putting a big if block in. And so that's broken down to a level where these things are separated. And as a rough glance, you can see that there's a series of compiler phases. They generally break down into cleanup, flatten columns, shape the SQL, and generate code.
So if you want to give a hint to that database compiler, say you want to modify an existing compiler, what's the API for providing that hint that you want to perform a particular optimization?
There are some raw SQL things. I don't know off the top of my head. I would have to look back at the docs. But there is, you can either update the code for the driver. There is some ability to generate raw SQL. So you may, for example, choose in a particular place to replace an AST call with actually just passing raw SQL in until you get an optimization in place.
I was just wondering if you could take a driver that exists and modify it such that you could add a hint and say, for this query, I want to apply this hint.
You can manipulate the code for the individual driver because that is the compiler that knows how to take that refined state down into SQL.
So in your Scala, how would you express that hint?
I believe you'd have to swap out the actual driver code as the thing stands right now. So you might have to provide an additional driver or modify the existing driver.
I'll clarification.
Yes.
What's the relationship between Slick and A-norm?
I don't know that I'm entirely familiar with A-norm. It sounds familiar, but...
The A-norm is kind of standard database access layer of play, which is basically based on SQL, and from SQL you generate objects.
So I know long-term Slick is part of the Typesafe stack, and so what I would expect to see is that we're going to eventually have play migrate over to Slick, the database layer. Whether A-norm will go away or not, I would be the wrong person to ask. James Ward would be the right person to ask that question. he knows the product direction on that.
Right now, most of the packages are provided, ANORM is the default.
Yeah, so I mean, I don't think there's any plans for ANORM to go away, but I do know that as Slick evolves and as the 2.0 release comes out, you're going to see more of it demoed with Play and integrated with Play and available for you to use.
It would be interesting to know why, the rationale for decision to kind of replace ANORM eventually with Slick.
Well, like I said, I don't know that we're looking to replace it. I think it will probably augment and sit alongside of it, but I would speak to James about that to get a good idea of what the direction is. No, not Jamie, but you might know, what's the plan for ANORM in the long term? Are we replacing Slick with it in Play, or are they just sitting side by side?
No, I think it'll be plugged. I think it'll be both. I don't see it going one, but I could be wrong.
Jamie's higher on the food chain than me, so you can blame him if it's the wrong answer. Yes?
And I have a question. At what point do you think you'd be able to use Slick with asynchronous?
So that's something we can talk about a little near. I'm almost done, but that is something that's on my roadmap after I'm done with the NoSQL stuff. We have been talking about this idea of pure asynchronous data access. I would say probably in the fall would be when we're looking at it. It's almost the fall, actually, now that I think of it. But probably late fall where it started to play with that. But I mean, the roadmap is set by someone else. And what I necessarily see in the next few months may not be how it is, but it is on our plans for the next couple of cycles that we do want to have potential JDBC level access like that.
So, is there a way that I can control a connection pool or connect to multiple database or sharding database?
There is. Can we hold that off until I'm done? I just want to go through a couple more slides. I just want to real quick show you guys a couple more examples of using Slick so you have something to take away with. Here I'm doing a sort, so I'm calling persons, got sort by name. I'm dropping 5 and taking 10. These translate down to SQL queries. I can group by the number of people per age. So mapping that, grouping by the age field. Again, this looks a lot like raw Scala code that will compile to SQL. I can pull out the first entry if I need to. So find me the persons who have the ID 3, pull out the first one. We do support, unions. So in this case, I'm creating a union of all of the persons whose age is less than 18 or greater than 65. And we do support null as well. And so if you look at this, we've created option columns. An option is a translation under the covers for creating a nullable column. So in SQL terms, that's a nullable column, but we want you to map a column that's nullable with option because that's good, safe Scala that gives you something that you're not going to get null back from the database. And so if I was to do a DDL create here, what I would create would be something with nullable field, but it would be translated as option in my Scala. Now,
You have to say 0.nullable. You actually want DDL.
I'd have to check that.
Yeah.
Finally, you guys were asking about outer joins. So this is an example of outer joins, left, right, and full. Now, I've got a tasks column and a person's a task table and a person's table. And I'm doing my join, and I'm just specifying tasks, outer join persons on. So it looks a lot like the SQL. Now, these question marks defined here are because it's possible with certain joins, like the right-hand side of a left outer join, or the left-hand side on a right outer join, or both sides for a full outer join, for us to have null values. If the join didn't match, it's possible that title and name could be null, because there is no left-hand side or right-hand side or anything else. If you've worked with these kinds of joins, you've seen that. And so dot question mark tells Slick, I want you to return me an option of the type, rather than the raw type, just in case it's null. And there are a number of column operators that are additional for doing all sorts of fun SQL-y things. A couple of other quick features. There is auto increment, there are subqueries, case statements, prepared statements, custom data types are possible, for each iteration, which we talked about, and a lot more.
Does that include cursors?
Well, cursors are implemented as fundamentally, they're part of Slick. They are, when you get back an iterator from a query, you are using a cursor under the covers. And then depending on the driver implementation, whether it uses the native cursors of the database would be really up to the JDBC driver. So there are some new backend architectures that are available in the 2.0 milestones. This includes type providers using type macros. This is going to greatly improve some of the stuff that seems a little overly expressive, like declaring our table types and other things, will be possible to automatically infer as type macros come around, and I think Macro Paradise is due for 2.11. There is distributed query, and if you're going to be at Java 1, I do highly recommend Stefan's talk. I've actually walked through his slides for Java 1. He's going to be talking about the direct querying system, the distributed querying system. What that actually lets you do is join against multiple data sources. So you could have an Oracle database and a SQL Server database, and you could do a join between the two, and we'll emulate that join in code and fetch the data from both databases. And that's something that's going to be available in 2.0. And ultimately, once we get Mongo in place, we'll probably implement joins in Mongo emulated using the distributed querying code. Also coming soon, as I said, SQL support. And we're talking about this reactive and asynchronous database support. And this is something, these are two things that I'm working on, that I'm excited about, that I'm hoping to have enough time to really put together. And so, it's something that we're open source, so we actively encourage contributors from the outside. If you have ideas or thoughts, please jump in, get on the mailing list, tell us what you think. And thank you very much. There's also, the Slick website is slick.typesafe.com. Our website is typesafe.com, as you may have guessed. And I know we jumped a bunch of questions in here. We probably have a couple minutes since there's no other talker coming on after me. Does anybody have any other questions? Yes.
There are no plans to introduce caching later, is that correct?
I don't know. To be honest, I'm not aware of any. That doesn't necessarily rule them out. I haven't heard anything about them. I know sort of the immediate future of the things that I just mentioned, which is the type macros, the distributed querying system. A lot of this is driven by user requests and customers that we're working with and other things. So caching is something that's interesting. I would suggest posting something in the mailing list, and let's get a discussion started and see if that's something that makes sense to put in there. I think usually caching is something that's separated out, but it might make sense because as part of the NoSQL stuff, it's also possible to look at more cache-like things like Memcache or Redis and use distributed querying or something else to move that into there. Multiple databases is handled by the distributed querying system that I just mentioned. So multiple databases with distributed querying, which will be in 2.0, we have the ability to pull in multiple. You're talking about joining multiple databases together.
Actually, just talk to different.
Oh, that's just a simple. That's just when you declare your session, you specify what host to connect to and what database, etc. What was the other one?
Connection pool.
Connection pool would be handled by the individual driver. I know we do support C3PO and Bone CP under the covers, because that's a JDBC thing. So you can specify the JDBC connection string to use those, and you can use those the same as Slick as you would in Java. Yes?
Transactions?
Yes, there are transaction support. Actually, Sanjay's been playing with them lately. There's just a with transaction function, right, instead of with session. So you just say with transaction. Also, all of the JDBC functionality applies. So you can set scoped at a thread level and other things, transaction stuff, just like you can in JDBC. But there's that loan pattern method with transaction available, and you have all the support that you would in JDBC for transactions available in Slick. Yes.
No support plan for I have to use stored procedures.
For which?
For I have to use stored procedures to get at this because it's in these days.
There is support for calling stored procedures. I don't know how hairy it is. So I don't know whether you could, I worked in a shop like that where all data access was written by the DBA and you had to call functions. And I'm sort of picturing exactly what you're asking, which is you'd like that nice table definition to map to a SQL stored procedure call. I'm actually not sure. I will ask about that because that's actually interesting. And like I said, I've worked in a shop like that where we had that as a problem. And it was one of the things that made it really hard when we moved over to EJB, was that we had no ability to customize any of the SQL statements. And the DBA got very mad when he was told, look, we're moving to EJB, whether you like it or not, you've got to get rid of the stored procedures. Because he saw them as his way of auditing and making sure people didn't make mistakes. Any one more question here? Anybody? All right, thank you very much, guys.